All right, today in Algebra 2, we're going to look at Section 3.3, Polynomial Identities. Okay, so our essential question, how can you use polynomial identities to rewrite expressions efficiently? After today, you should be able to prove and use polynomial identities. So, first, what is a polynomial identity? A mathematical statement that equates two polynomial expressions is an identity. So, is an identity if one side can be transformed into the other side using mathematical operations. These polynomial identities are useful tools to multiply and factor polynomials. So here we have a list of them. We need to memorize these, okay? Difference of squares, we already know this one. A squared minus b squared, it factored to a plus b and a minus b. Sum of a square, okay, or square of a sum. A plus b quantity squared, if I multiply that out, again, we already know this one because this was the shortcut I taught you guys. The very first one squared, a squared, plus 2ab, so you multiply them together and then double it, plus b squared, the last one squared. So really, the difference of cubes and the sum of cubes, these are the new ones that we have to learn, okay? So a cubed minus b cubed. That factors down to a minus b times a squared plus ab plus b squared. I don't know what happened to my parentheses there. So I take the cubed root of the first one, cubed root of the second one. I keep the same sign. Then I take my small set of parentheses, I square the first one, I multiply them together, I square the last one. I change the sign here. A cubed plus b cubed, again, cubed root of both of them gets me a and b. I square the first one, change my sign, multiply them together, and last one squared. So we're going to prove a polynomial identity. Don't worry, these proofs are not like in geometry. Okay, so prove the sum of cubes identity. So the sum of cubes identity, okay, we want to prove the a plus b times a squared minus ab plus b squared. We want to prove that when we multiply all of that out, we would get a cubed plus b cubed. Okay, so in order to do that, we simply need to multiply. Okay, so I need to first distribute my a with everything in there. So a times a squared gets me a cubed. A times negative ab gives me negative a squared b, and then plus ab squared. Now I want to distribute my b. So I get plus a squared b minus ab squared plus b cubed. Now I'm going to combine like terms. So this is the only a cubed I have, so a cubed. A squared b and a squared b, they cancel each other out. ab squared and ab squared, they cancel each other out, and I'm left with plus b cubed. So that's what I got. So I can say a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. We just proved that. So now let's prove the difference of cubes identity. So the difference of cubes identity says a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. So we're going to prove this by multiplying out a minus b times a squared plus ab plus b squared. So again, if I multiply this, I start with my a, so a times a squared gets me a cubed plus a squared b plus ab squared. Now multiply my negative b through, so I get minus a squared b minus ab squared minus b cubed. Combine like terms. A cubed, a squared b's cancel each other out, ab squareds cancel each other out, and I'm left with minus b cubed. So we just proved a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Okay. All right, let's go to the back. It says use polynomial identities to multiply. Okay, so 2x squared plus y cubed, all of that quantity squared. Instead of writing that out twice and FOILing, we're going to use the shortcut. We've been using the shortcut. I've taught you the shortcut earlier. So the shortcut says I take the very first term and I square it. So 2x squared squared. Plus, I multiply the two terms together and then double it. 2 times 2x squared y cubed plus the last term squared, so y cubed squared. So now I want to work this out. So 2x squared squared, I have to square both of them. So 2 squared gets me 4. X squared squared, remember power to power, I multiply my exponents. X to the 4th. Plus 4x squared y cubed plus y cubed squared, multiply my exponents, y to the 6th. Nothing to combine, no like terms, there's my answer. 41 times 39. If I can turn this into an a plus b and an a minus b. So we're just going to show you another way instead of working out 41 times 39. I'm going to show you another way to do that. Okay? So if I turn it into an a plus b and a minus b, so what's another way that I could write 41? I could write 41 as 40 plus 1. Another way I could write 39 then would be 40 minus 1. That gets me an a plus b and an a minus b. A is 40, b is 1. Okay? So now this is a difference of squares, right? So I see that this is a difference of squares. I'm going to factor it down because I have 40 plus 1, 40 minus 1, so I know that that came from a difference of squares. So the difference of squares that it came from, okay, would have been 40 squared minus 1 squared. So then what's 40 squared? Well, that's an easy one. That's 1600. 1 squared is 1, so 1600 minus 1 is 1599. So 1599 is what I get when I take 41 times 39. It's just a way of being able to work that out without a calculator or without having to manually do all of that work. Okay? Recognize that you can turn it into a difference of squares. Let's try another one, okay, where we just have numbers. So 12 plus 15 quantity squared. So this, right, was our perfect square, right? A sum of squares. So we're going to factor this one. Sorry, not factor. We're going to expand this out as the sum of squares. So the sum of squares says I take the first one and I square it. So this would be 12 squared. I multiply the two terms together and double it. So 2 times 12 times 15 plus the last term squared, 15 squared. 12 squared gets me 144. 2 times 12 gets me 24. 24 times 15 gets me 360. 15 squared, 225. So now I just have to add all those up. So let's see, 3, 4, 5, 6, 60. We're at 729. So 12 plus 15 squared. Again, instead of adding the 12 and the 15 together and then squaring that number, this is just another way that I could work that out. Number 4, and this is using identities. 3x squared plus 5y cubed times 3x squared minus 5y cubed. Okay, so I know that this would have come from a difference of squares, right? Because I have the exact same thing, only 1 plus 1 minus. So this would have come from a difference of squares. So this would have come from my first term, 3x squared squared, minus my second term, 5y cubed squared. So now just square these. So I get 9x to the 4th minus 25y to the 6th. Much easier to do it that way than FOIL and combine like terms. Okay? So now we're going to use polynomial identities to factor and simplify. So the first one, factor 9m to the 4th minus 25n to the 6th. I notice that 9 and 25 are perfect squares. So, and I have a subtraction, so this is a difference of squares. So 2 sets of parentheses. The square root of 9m to the 4th, so 3m squared, 3m squared. 1 plus, 1 minus. square root of 25n to the 6th. Okay, so that is 5n cubed, 5n cubed. Because remember when we reviewed our exponents, I'm looking for 25n to the 6th. Okay, is something quantity squared. I know the 25 is 5 squared. So n, okay, what times 2 gives me 6? 3, because remember powers to power I multiply. So that's how I know that that's what it factored down to. X cubed minus 216, x cubed, that's a cube. So then I'm checking, is 216 a perfect cube? It is. So this is a perfect cube. So then we have that identity that we have memorized for the difference of cubes. So it takes the cube root of both of these. So the cube root of x cubed is x. I keep the sign minus. The cube root of 216 is 6. Then my next set of parentheses, I take this first term and I square it. So x squared. I change my sign. I multiply these two together. 6x. And then plus the last one squared. 6 squared, 36. There we have it factored. Now we're going to take 11 cubed plus 5 cubed. Again, I have this time a sum of cubes, right? So it says take the cube root of the first one, 11, plus the cube root of the second one, 5, times the first one squared, 11 squared, change my sign, multiply the two together, 5 times 11, plus the last one squared, 5 squared. Now I can work this out. Okay. So 11 plus 5 gets me 16. 11 squared is 121, minus 55, minus 25. So here I get 16 times, let's see, 121 minus 55 plus 25 minus 9, or sorry, times 91. Multiply those two together, I get 1,456. Again, this is just another way to work that problem out using identities. Okay. Next page, I have m to the 8th minus 9n cubed. Again, I notice that my number 9 is a perfect square, so I'm checking to see difference of squares. Okay. So again, m to the 8th. I want to see that would be m to what power squared. So what would I have to multiply 2 by to get 8? 4. Okay. Into the 10th, into what power squared? So what do I have to multiply 2 by to get 10? 5. So this would factor to m to the 4th plus 3n to the 5th times m to the 4th minus 3n to the 5th. 12 cubed plus 2 cubed, again, they are both perfect cubes, so use that identity. So the cube root of the first one, 12, plus the cube root of the second one, 2. First one squared, 12 squared. Change my sign, minus 2 times 12, multiply them together, plus the last one squared. So here 12 plus 2 gets me 14. 12 squared is 144. 2 times 12 is 24. 2 squared is 4. So I have 14 times, let's see, 144 minus 20, 124. Multiply those two together, 1,736. Last one of these, number 6, it says 27x to the 9th minus 343y to the 6th. Right? 27 and 343, I recognize those as perfect cubes. So this is a difference of cubes. So the cube root of the first one, the cube root of 27 is 3. Okay. X cubed would have gotten me the cube root of x to the 9th. Minus 343, the cube root of that is 7. Y to the 6th, again what I'm doing, okay, y to what power, okay, when I cube it, it gets me 6. So 3 times what number gets me 6? Y squared. And again, that's how I found my x over here. So I was looking x to what power when I cube it. So 3 times what gets me 9? 3. So 3x cubed minus 7y squared. That's my first set of parentheses. That's the cube root of both of those. I have to take this and I square the first term. So 3 squared is 9. X cubed squared is x to the 6th. Change my sign. So plus, multiply these two together. 21 x cubed y squared plus the last one squared. So 7 squared is 49. Y squared squared, y to the 4th. There's my answer. And again, you need to memorize these identities. Next, we're going to talk about what's called Pascal's triangle. Here it tells me that the coefficients of x plus y quantity to the n power are produced by adding the coefficients of x plus y to the n minus 1 power, producing an array known as Pascal's triangle. The triangular pattern of numbers is where each number is the sum of the two numbers diagonally above it. If there's not a second number diagonally above it in the triangle, think of the missing number as a 0. Okay? So we see that if I have x plus y to the 0 power, I just have 1. So my first row would be x plus y to the first power, okay? 1 and 1. X plus y quantity squared multiplies out to give me this. Okay? So my coefficients 1, 2, 1, 1, 2, 1, 1 and 1 get me 2. 1 plus 1 gets me that 2. X plus y quantity cubed, if I multiply it all out, gets me this. My coefficients 1, 3, I repeat my 3 and then a 1. Again, diagonal above it, 1 plus 2 gets me 3. 1 plus 2 gets me 3. X plus y to the 4th power. Again, 1, 4, 6, 4, 1. 1 plus 3 gets me 4. 3 plus 3 gets me 6. 1 plus 3 gets me 4. So it says use Pascal's triangle to expand x plus y to the 6th power. Well, let's do the 5th row. X plus y to the 5th. I'm going to expand my row out. Okay, so I know I would have a 1 and then a 5. 6 plus, because 1 plus 4 get me 5. 4 plus 6 gets me 10. 4 plus 6 gets me another 10. 4 plus 1 gets me 5, and then my 1. So now I can do x plus y to the 6th power. So I have my 1 out here. 5 plus 1 gets me 6. 5 plus 10 gets me 15. 10 plus 10 gets me 20. 10 plus 5 gets me 15. 5 plus 1, 6. And then my 1 out here on the end. So this is going to be my extension. And again, we kind of lost that 1 out there. Let's rewrite that. Here's my 1. So these are my coefficients. Okay? So I would have x to the 6th, 1x to the 6th, plus 6x to the 5th y. So as my x's decrease, my y's are going to start increasing. Plus 15x to the 4th y squared plus 20x cubed y cubed plus 15x squared y to the 4th plus 16x y to the 5th plus y to the 6th power. See, if we memorize Pascal's triangle, know that pattern, how easy that was to multiply all of that out instead of having to write x plus y times x plus y 6 times and then FOIL. Much easier to do Pascal's triangle. All right, that is all of section 3.3, polynomial identities. Again, you need to memorize these identities for the difference of squares, the sum of squares, which we already know those two, and then the difference of cubes and the sum of cubes. Please memorize those. You will need them